We like kids, just trying to make a difference with kids, help them get prepared, either college readiness or career readiness once they get out of high school. Hopefully at least some of them go into some sort of technical field, electrical engineering, mechanical engineering, software programming. I think we got some positive momentum going in that direction today. A lot of excited kids, a lot of excited parents, a lot of excited teachers at this young influential age. I think it's important that kids catch a fever or a passion about something. The theme's kind of really, it's kind of meltdown at the reactor. We kind of came up with the theme with about the same time that they had that tsunami and the reactor problems that they had in Japan. So like, that sounds like real life, and I think they actually had a lot of robotics cleaning up the reactor at the Japanese nuclear reactor site. So that's real life, that's a good application for robotics. So that's what we'll make the theme for this year. We're trying to mimic real life as much as possible. Section 1 and 2 are autonomous navigation. Section 1, most teams use the ultrasound sensors to bounce sound waves off the walls and navigate onto Section 2, which is they're using light waves to detect the line and pick up on that. And that's really true robotics, and that's probably the most difficult, most programming intensive part. But you know, I always say, you know, if it's not autonomous, it's not robotics. It's really cool machines, but if it's not autonomous, if the robot doesn't have the ability to perform some task autonomously without human intervention, then it's not truly robotics. It's just big RC or big machines that are cool. And the autonomous challenge obviously is the most difficult. And then they switch into manual mode. There's a design challenge there where they've got to construct a claw or an end-of-arm tooling and pick up the fuel rods and kind of contain them as kind of the thing. Woo! And then next phase is pick up the disaster victim. They got the little dude there. If they don't contain the reactor fuel rods within a certain time period, then the little dude turns into the Hulk from overexposure to radiation. And so that's a little bit of a mechanical disadvantage because it's a little bigger, a little heavier. And then the last phase is they got to get out of the disaster wreckage with the disaster rescue victim. Well, I hope they're learning some hard lessons about teamwork, you know, integration, systems integration. Obviously the mechanical systems have to work with the electrical systems and the software, and obviously if all three of those systems aren't working, they have little problems and glitches and things like that. There's definitely a commitment factor. I mean, the teachers and kids have been putting in weekends, they've been working after school. But that's, you know, we try to make it as close to real life as possible, and that's real life. You know, you don't really get an A for showing up and breathing in real life. If you want the good job, the good promotion, you know, if you're a business person and want your business to grow and win the contract, it's all about extra effort, extra creativity, surpassing the competition with extra effort. I just want to see a lot of kids getting excited in STEM education, robotics education. There's a lot of different elements of STEM. I do like the robotics because it combines multiple aspects of engineering, mechanical, electrical programming, getting those three pillars to work together. And the more kids involved in STEM education, then the better off we'll all be. And we're just trying to do our little piece of getting kids excited about robotics and STEM education. Watch the kids, look at the robots, get excited, and just jump in and try to help make a difference. If you're passionate about kids and passionate about robots, then probably a good fit for you.